second exam. Mondays and Wednesdays there, we're probably going to need to stay a little bit longer than, we'll probably go a little bit beyond 10:15 as the scheduled lecture time here. Since we're not doing labs on Mondays and Wednesdays there, and we have some time in this room here, and we'll try to fit whatever material we need to fit in there. So just a fair warning, be prepared. Things are going to, the pace is going to pick up a little bit more if this is not intensive enough. So gas law, and you can see that the stoichiometry and the gas law, and it's a lot of calculation involved. But really, once you finish doing all the practice there, and you will realize that's really, all of these calculations really nothing new. It's dimensional analysis. All you need to do is to identify the conversion factor. And then when you plug in the conversion factor, as we try to be consistent when we show you how to do dimensional analysis, always multiply the quantity you're converting by the conversion factor. Focus on the unit. Cancel out the unit, you end up with the correct answer, what the question is asking you. Now, if you end up with something that's not the question is asking you, well, there's a problem with the setup. Okay, so I was asked a question there yesterday, I think, or probably on Monday. I couldn't remember. A student in my afternoon class and came to my office and asked, how did you learn chemistry when you were in college? And that put me on a long pause, and I was thinking back the years that I was learning chemistry. And we definitely have, and I was born and raised in China, so we have a completely different educational system. And I just, her question just brought me back to those horrible memories there. And when we were taking chemistry classes there, the instructor basically, this is what you need to memorize. Okay, all these equations, all these formulas, you need to memorize. The next day, this is what I'm going to test you. So my experience really is that when I memorized a lot of things, the time that I was learning chemistry, initially started learning chemistry there, I memorized a lot of things that I don't quite understand. And the benefit of that really is that you have a lot of information in your head. And then as you go along, you pick up all these different pieces of information there. Eventually, it all comes back to you. Oh, okay, this is what I memorized. That's why we have this equation. That's why we do calculation in this way. So that, I guess, is a different approach in East and West and whatever you want to categorize it. And I think there's a benefit and there's also a drawback there, because a lot of kids, when they're learning chemistry, if they don't understand why they're being asked, what the reason that they're being asked to memorize all that information, if they don't understand the reason, if they don't understand what they are trying to memorize, many of them are just going to be burned out and say, well, I'm not dealing with this, forget about it, I'll go to social science and English, and Chinese maybe. Forget about the science there. But those who survived and end up understanding the topic much better. I vividly remember my experience when I came to grad school here in this country, and the first graduate level chemistry course I took was a review course of organic chemistry. Now, when I finished college in China, organic chemistry to me is basically memorization plus memorization plus memorization. There's nothing logical, there's nothing reasoning in chemistry, organic chemistry at all. So I memorized a lot of different types of reactions without understanding, even after college, and without understanding why the reaction happened the way it happens. And then the first graduate level course I took at University of Missouri, Kansas City, Professor Pop, and he was doing a summary of what's covered in undergraduate organic chemistry. And he's not talking about name reactions there, because in organic chemistry we have a Diels-Alder reaction and a Friedel-Crafts reaction, and all those different organic chemists who discovered those reactions, use those reactions to synthesize different things that we can use and in our everyday life there. So we name those reactions after them and in honor of their research. I memorized a lot of reactions there, never understood why those reactions happen, how those reactions happen. And then when I took that survey course, And basically it's a summary of undergrad organic chemistry classes there. My professor there said, well, let's talk about why the reactions are happening. And we use the term mechanism of the reaction. So he was, well, there are 10 different categories of organic chemistry reaction. As long as you know these 10 different categories there, you understand organic chemistry. So he was going one by one and talking about the details of how reactions happening instead of just memorize the reaction. And once we understand, or with all that information accumulated in my head already, and when I finished the undergrad organic chemistry class there, after taking that class, I just, wow, okay, now I understand organic chemistry at a much higher level, much different level there, and it's no longer pure memorization. So that's how that question on Monday from that student in my afternoon class there just brought me back to my own experience of learning chemistry. And for this particular course, though, in the summer, it's very intensive. So it may appear at times that it's just about memorization. You have to memorize a lot of definitions. Well, that's part of it. Okay? And when I started to teach chemistry, I still emphasize on the memorization part because I see, through my own personal experience, I see the benefit of memorizing the information, even at the time when I was taking chemistry without understanding why I'm asked to memorize all these different things there. And I see the benefit of that. The educational system here in this country, really, from grade school K through 12, you see an approach where it's, you don't have to memorize anything. It's in a book, you can look it up. Well, no. When you study something like chemistry, you gotta memorize some of the important things there. I remember first day when I was in chemistry class there, and the teacher just say, well, this is what we call periodic table. Memorize all of it. Why? Well, just memorize it. I'll test you tomorrow. So that's how I was taught about the chemistry there. And there's a benefit for that to that approach. And it's not all bad. I think the drawback, as I mentioned there, is that students sometimes, and people who are not interested in this particular topic, they may become interested if you tell them why, but if you simply tell them, just memorize this, and that's, well, I'm not dealing with this. So they will take a different approach and different path. So we might have missed quite a bit of great chemists in that approach there. However, the approach that are being used in this country, and I don't know how many of you have heard this in the grade schools there, and they're talking about common core. And you have to set up the equation in a certain way, and you have to explain certain things in a certain way. Otherwise, you don't get the credit there. And you don't have to memorize this. You don't have to memorize now. There's a different approach there. When I'm teaching chemistry, though, I think one of the greatest benefit is that showing when we're doing calculation, we don't just tell you, just memorize this. Divide in this particular situation, multiply in another situation. Just memorize it, and you will understand why. Well, eventually you will. But the thing here is that we want to give you an approach, and how do we set up the equation? Why do we do calculation this way? And that will make, to me, I think, and that will make more sense. And to the first time student in chemistry classes there, you tell them how to set up the equation. That's the key there. Once they know how to set up the equation, well, the rest of it is easy. And of course, you need to know some basic math.